Good morning and good afternoon to everyone, and welcome to this webinar from ColdJet regarding sustainable cooling solutions in the form of dry ice. We're going to speak about how we use dry ice, especially in the food industry. It's ColdJet. ColdJet is a global company with 14 sales offices around the world. We have 3 R&D hubs, we have 3 manufacturing sites, and we have 14 service centers in the customer service organization. So we are able to service any part of the world at this point. What is dry ice? Dry ice is actually CO2 in a solid form. CO2 is produced by, for example, fertilizer companies, by refineries, by biofarms. These emissions are then captured or recovered instead of blowing into the sky and used for making dry ice. The liquid CO2 will be stored in usually tanks. It is distributed by tankers and then brought to local sites where they're using the liquefied CO2 is being converted into dry ice. What do you need in order to make dry ice? Well, first of all, you need a tank. This is normally supplied by the CO2 supplier, like the gas companies. It is supplied by tankers. From the tank, you have the liquid CO2 going to the pelletizer, and the pelletizer will then transform the liquid CO2 into dry ice. This is one of ColdJet's pelletizers. We have them in various capacities from 80 kilo up to 750 kilo per hour. How is it done? The pressurized liquid CO2 is being fed into a depressurized inner chamber where the liquid CO2 becomes solid CO2 snow. This snow will then have to be compressed through a die, and this is where we actually find the dry ice, the final product. So what's so cool about dry ice? Dry ice is minus 78.5 degrees Celsius. It has 2 times the refrigeration power of water ice. During energy transfer, it sublimates, meaning it's going from solid back to gas again, but without leaving any water or any kind of residue, like, for example, wet ice. Wet ice turns into water. The product does not need to be in direct contact with the dry ice because the gaseous phase transfer energy will cool the product. It is safe around food. It's already being used in the food industry, and it is approved by the FDA, the USDA, and the EPA. And the dry ice is made of recycled CO2, so we are not adding anything to the CO2 emission at all. Where is dry ice used? Dry ice is used in a fair number of applications, like food transportation, for example, for life science, in the food processing, with dry ice resellers. And we also have something called dry ice blasting. Oops, running away here. Market trends. Oh. Seems to have a glitch here now. Market trends shows, let's take this one then. Sustainable cooling. Where do we use it? We use it in meat processing, for example, for cooling in the offal line, for cooling meat products on the trim line, for cooling during mixers and blenders to make sure that we keep the temperature low. And also during the transportation of the final product, we use the dry ice. Dry ice inhibits the growth of microbiology because we are having a much lower temperature at the finished product due to the low temperature of the dry ice compared to other cooling methods. This is a real return on the investment exercise from a poultry processor in California. They were using 38,000 pounds of dry ice every week to cool and freeze its trim lines and the shipping processes. So if you look on the right side, you will see that the return on the investment was only 7 months by using dry ice for cooling. Sustainable cooling is used both for fresh and frozen product in regional and global intermodal shipping. The value of dry ice over traditional gel packs or water ice for shipping is that due to the low temperatures, we inhibit the growth of bacteria, so we have a very good product quality and safety, and we increase actually the shelf life of the final product itself. Could be seafood or meat. We reduce the transportation cost, we reduce the carbon footprint, and we eliminate the biopollution. In this case, for seafood, for example, we can use different kinds of packaging material. We can use styropor, which is normal way. We can also use the dry ice directly on the food or covered or separated by a piece of cardboard or piece of plastic. Dry ice sublimates and transfers energy into the product. So that means the process will take around 4 to 6 hours, depending on the fish temperature and the outside temperature. There is no weight from the dry ice at the airport scales. For example, if you are shipping out seafood to faraway destinations, you will add the dry ice at the production site, and when it arrives at the airport, the dry ice has evaporated, but the low temperature keeps the seafood cold for much longer time. It actually becomes its own refrigerant. When used in conjunction with water ice, it keeps it around 0 degrees and thus lasting longer as well. This shows the temperature levels achieved during transport from Norway to US with seafood. In the middle figure here, you will have the water ice, where they're spending 4 kilos of water ice in the packaging, and the below is where you're using dry ice only, and only 2.5 kilos of dry ice. And remember, those 2.5 kilos of dry ice will have evaporated when you reach the airport. You can see the stability of the temperature is much better than if you were using wet ice. This validates the value proposition compared dry ice with water ice. In these first two cases, you have the whole salmon, which will have a shelf life of about 24 days, compared to water ice, where the shelf life would have been around 16 days. Talking about fillets, you will have a shelf life of 16 days, compared to if you were using wet ice of around 11 days. These are two examples of using dry ice for transporting fresh seafood to Vietnam, for example. Over here, the whole transportation time took 87 hours, and you can see how quickly the temperature drops from the packaging point of view during the whole transportation time until arrival. This one is for Japan, where the transportation time was 52 hours. Again, you see a clear picture of a rapid decrease of temperature and staying stable around zero or just below zero for the entire time of the shipment. And again, remember, at this point, the dry ice has evaporated, so the end product actually uses itself as a coolant. In some cases, we are combining dry ice and water ice due to mainly for when producing a whole fish, for example. And this is mainly because whole fish, we need to make sure that we remain the red color of the gills, which is an indicator of freshness. So you would use 1 kilo of wet ice with 0.7 kilo of dry ice together. For dry ice, we use mainly only dry ice. The only thing is that the fillets have been covered by a sheet of plastic. And you can see here at the arrival, the temperature of the salmon is still just below 0 degrees. A case study on freight costs. A company producing 3.5 tons of fillet per year, they need 175,000 boxes per year. In total, the transport cost comes to a bit over 1 million euro to ship dry ice. And you have an emission of about 7,000 tons of CO2 emissions. And this is when you're using wet ice for the transport. The same thing, but using dry ice only, you will save 960,000 euros on the transport, and you will reduce the carbon footprint with 6,750 tons. So a significant reduction of both the transportation costs and also the carbon footprint. Dry ice is also used for road transport, and in Europe, you will gain the same things as you would if putting on a plane. You will still reduce the transportation costs, and you can even say that you are not you don't have to use refrigerated trucks for transporting the seafood or any kind of other food products. This has a big impact on the emission as well. The total cost of ownership, comparing water ice with gel packs and dry ice. The first column is the water ice, where you have a high amount of transportation costs. On the gel packs, again, you have a high amount of transportation costs. And on the dry ice, here you have higher capital cost compared to water ice or gel packs. You have raw material cost, which is higher than gel packs and water ice. But in total, with the low transportation cost, the total cost of ownership using dry ice only is equivalently much better than water ice or gel packs. And other benefits are, again, the product quality and safety, the increased shelf life, the reduced transportation cost, the reduced carbon footprint. Which system is best for your operation? Well, that depends on what kind of product that you're producing. Is it fresh or frozen? Where are you going to be shipping to? Is it by road, long distance? What kind of packaging are you using? What transport method are you using today? Do you have any space constraints or quality or labor issues? Also, your company's ESG targets is a point to consider. The line capacity, ventilation, air exchange. But all these questions, we will help you answer those and find out which solution is the best for you. It can be an online, direct online solution, or it can be indirect solution. This is to show you how the dry ice journey is. In this upper case here, you have a pelletizer or the dry ice production in a remote place. So that is a third-party supplier. He will then ship the containers of dry ice to your place. In containers, you will usually handle the dry ice manually. However, if you produce your own dry ice, there will be no handling because Coaljet can offer a complete turnkey installation, fully automatic. Also, the difference between getting your dry ice from a third party or producing your dry ice usually gives you a significant amount of savings on its own. The DS series is one of our inline systems. We can feed dry ice up to 16 boxes per minute. This is a solution for both the seafood, but also for home delivery companies, for example. We can automatically create detection and dose the quantity needed for each individual box, like depending on how long the distance to the end of the product. So we don't give away dry ice, we just add in the needed dry ice, no more, no less. It's electric driven, so there's no contamination dangers from hydraulic liquid or anything like that. This shows you a DS line with one of the major salmon producers in Norway. Again, by using dry ice, or even in the combination dry ice and wet ice, due to the low temperature that we are creating, you will have a much less regrowth of bacteria. You will increase the shelf life for seafood, for example. We are talking an increased shelf life of 3 to 5 days. You will have a significant reduction in your transportation costs. You will have a significant reduction in your carbon footprint. And you also eliminate any biopollution because there are no residues when using dry ice. When you produce dry ice, you are wasting about 55 to 60% of the CO2. By adding our recovery system, you can change that, and you will have a loss of 10% or lower by adding the recovery system. These are some of the solutions that can be one of many solutions for your company. In each individual case, Coaljet will supply you with a turnkey solution based on if it's a meat industry, if it's seafood, if you have space constrictions or similar, and also your capacity. Coaljet supplies the most efficient pelletizer on the market. Our technology gives you a lower ratio compared to similar products in the market. We have pelletizers starting from 80 kilo an hour up to 750 kilos per hour. So the solution that Coaljet will provide you will depend on your capacity and your need for the dry ice. We got through all of the slides, and at this point, if any of you have any questions, feel free to put them into the Q&A box on your left, and I will be happy to answer any questions you may have. If not, you can go on to our website, Coaljet's website, and Here you can put in any questions you may have regarding production of dry ice in general, or in combination with exactly your industry, because dry ice is used in more than 16 different industries in the world today. No questions at this point? Right. In this case, I would like to invite you to either send me the questions you may have through our website. In this case, I would like to wish you all a good afternoon or a good morning again. Thank you for joining this webinar, and see you shortly again. Thank you.